Weather and illusions. A rainstorm moving towards an aircraft can give a false illusion that the rain horizon is moving lower. The pilot lowers the nose or reduces power. A layer of clouds can give an illusion of a false horizon. If the actual horizon is absent due to poor visibility, a pilot may use the level indicated by the layer cloud. Rain on the windscreen can make the runway look closer than it actually is. Heavy rain can diffuse the glow from the approach lights, making them look further away than they are. And descending into shallow fog can give a false illusion that the aircraft has pitched up. The pilot's correction is to pitch the nose down. The frontal system. At the centre of the frontal system is low pressure, and the surface of lower winds are being drawn into the low pressure centre. The warm front is shown at the surface with semicircles which are filled in and in colour red. Behind this is a warm sector. After that comes the cold front, depicted with triangles which are filled in with blue if they're in colour at the surface. Behind the cold front is the cold air mass. Frontal systems. Frontal system. Definitions. The warm front, warm air is displacing cold air. The cold front, cold air is displacing warm air. An occluded front forms when the cold front overtakes the warm front and lifts the warm air off the ground. Clouds and rain are possible. Stationary fronts are when cold and warm air masses are next to each other. Neither air mass advances. Occlusions. A warm front occlusion has the appearance of a warm front coming. Ahead of the warm front occlusion will be cold polar air. Behind the warm front occlusion will also be cold polar air, but it won't be as cold. This makes it want to rise above the colder polar air. Most of the rain band will be ahead of the surface position of the front. And there'll be a mixture of warm front and cold front clouds at the occlusion with embedded CBs. The cold front occlusion has a cold front at the surface position. It's the coldest polar air now undercutting less cold polar air. This also has the effect of lifting up the tropical maritime air. The rain band will be at the surface and behind the front, but again there'll be a mixture of both warm front and cold front clouds with embedded CBs. Weather across fronts. Ahead of the warm front, pressure will be falling, the temperature will be up and the wind will be beginning to back. After the warm front has passed, the pressure will be steady, the temperature will be steady and the wind will be steady. And behind the cold front, the pressure will be rising, the temperature will be falling and the wind will back. At the surface positions of the fronts, in the northern hemisphere, the wind will veer and there'll be low pressure. Frontal systems. This is a depression or low as presented on weather charts. For low pressure, a cyclone in the northern hemisphere, there'll be low level convergence with ascent of air and high level divergence. For high pressure at the surface, an anticyclone in the northern hemisphere, there will be low-level divergence, descending air, and converging air at altitude. In a convergence zone, there's intense lifting activity, low-level surface convergence, and upper-level divergence. Air masses affecting the United Kingdom. Typically winter only is Arctic maritime, which is unstable, moist. It contains CUs and CBs. Polar continental is typically winter time, but can occur in early summer. Comes from Siberia and is cold, dry and stable, but picks up moisture over the North Sea. Tropical continental tends to be summer only, and it's hot, dry and stable, coming from the African continent. Tropical maritime occurs all year round. It's warm, moist and stable, and reaching the cooler waters nearer the UK, stabilises from beneath to form layered clouds. Polar maritime is cold, moist and unstable, the source region near Iceland. This northwesterly flow becomes more unstable and brings rainfall or snow depending on the time of year. Returning polar maritime has the same source region as polar maritime, so has the same characteristics, but takes a long route round and then tracks round along the same path as tropical maritime, therefore taking some of the characteristics of tropical maritime air. It's likely to have upper air instability. Insolation. The rays of sun are typically focused on the equator. Hence, the equator is heated more intensely than the rest of the world. World pressure systems. Pressure systems over the land and oceans. Over land in the summer, we tend to get orographic lows, thermal lows and polar front lows. And in the winter, the Siberian high, for example. Over the sea in summer, a good example would be the Azores high, and over the sea in winter, low pressure. The ideal Earth model. The equator has much heating, and this results in an equatorial trough of low pressure. This air rises and then tracks northwards and southwards, cools and descends around about 30 degrees north-south, forming a belt of tropical high pressure. This high pressure can flow back towards the equator or polewards towards the temperate region where there will be low pressure and ascending air. This ascending air can travel polewards and descend at the poles, resulting in a polar high. This allows various cells to form. The one near the equator is called the Hadley cell. The one at intermediate latitudes is the Ferrel cell, and the one at the poles, reaching the poles, is the polar cell. The intertropical convergence zone. The ITCZ follows the sun, about a month behind it. It's the intense surface heating causing a lifting process, convergence and convective activity. The red dotted line shows the position of the ITCZ in July, and the white dotted line shows its position in January. World weather systems in July. This will be summer in the Northern Hemisphere. The Icelandic low is a semi-permanent feature all year round. There'll be low pressure over North America and Asia and Russia. There'll be hurricanes in the Caribbean, and the Azores high will be extended. You can expect cyclones and typhoons around India and Japan respectively. In the southern hemisphere, there'll be high pressure over land and low pressure over the seas. World weather systems for January. This will be winter in the northern hemisphere. The Icelandic low is a semi-permanent weather feature. There'll be high pressure over North America and Russia. Travelling polar front depressions will be further south from Florida to the southwest of the UK. There'll be a northeast monsoon emanating from Siberia along the coast of China and Japan, heading towards India, which produces advection fog and drizzle near Hong Kong. In the southern hemisphere, there'll be low pressure over land and high pressure over the sea. There'll be cyclones associated with the intertropical convergence zone. Local winds for the Mediterranean. The Mistral flows through France. It's a valley katabatic wind with a north-northwesterly direction in the winter. The Bora is also katabatic and comes across Yugoslavia, or the former Republic of Yugoslavia, and the states around there. It's north-northeasterly in direction, a winter phenomenon. The Von der Waal is a west-southwesterly wind whipping through the Straits of Gibraltar into the Mediterranean in winter. Morocco has the Sirocco, as does Algeria, a south to southwesterly wind in the winter. Libya has the Ghibli, a southerly wind, and Egypt has the Khamsin, south-southeasterly, all in the winter. So the general flow is into the Mediterranean basin in winter. In summer there are Artesian winds which are north-northeasterly over Greece, and the Levanta which blows out of the Med near the Straits of Gibraltar. Here's a satellite image of the Ghibli, which is a southerly wind blowing through Libya across the Mediterranean Sea. You can see the sand that's being carried across towards Italy and Greece. Local winds for South America. These include the Zonda, the Sudestada and the Pampero. Significant weather charts are used to portray weather, typically at altitudes, for flights. They'll have on them the pressure systems and areas of low and high pressure. There's a geostrophic wind scale depicted on this one, which would enable you to determine wind speeds from the distances between isobars at various latitudes. The UK low-level wind chart, known as Form 214, is produced by the Met Office, and this enables, for various altitudes, wind direction, wind speed and temperature to be read.